Hi guys, welcome to the skillsurfacademy. Today, I will explain how to design a rectangular beam by using the PROKON software. Right, so let's move. Now here, this is the rectangular beam. Okay, brick wall is supported on the beam up to 3 meter height. Width is 225 millimeter width. We'll define the material first. So we'll assume we'll use 25 grade 25 concrete and steel grade. Main steel grade is 460 Newton per square millimeter, and unit weight of the concrete is 24. Right, breadth of the beam will consider as 250 millimeter and depth 300. Later on, will decide how to predetermine the depth of the beam. Live load on the beam is 6.5 kilonewton per meter. Brick wall load 15 kilonewton per meter. Okay, let's move. Now, initially, first we have to determine the initial size of the beam. For example, depth. As per the UK design manual, it says in the table number 4, for the simply supported beam, span or effective depth ratio is 12. So span is 3000. So ratio is 12. So we can obtain D as a required depth. Effective depth is 250. So this is the effective depth, not the height of the beam. So how to determine the height of the beam? So effective depth, we have to add the cover plus we assume link as a 6 mm and the main bar diameter is 16. So half of the bar diameter. So we obtain height, required height is greater than or equal to 180. So we'll assume 300 millimeter. Size of the beam 250 millimeter, width height is 300 millimeter. So what are the loads are brick wall load is 15 kilonewton per meter. Standard brick mean for the 3 meter height. So 3 meter height 225 we can consider as a 15 kilonewton per meter for engineering brick. Live load is 6.5. Okay, now this is a summary. You can see the screen. So this is the beam. Here to here 3 meter. Okay. So dead load on the beam is 15 kilonewton per meter brick wall load. Live load on the beam is given as 6.5. Okay. Now these are the loads. Now what is the section size? Is the beam. Here we have bar, we assumed as 16 millimeter bar. This is the link. Effective depth defined from here to here, center of the main bar. As per the BS code, this is the height of the beam. Is 300 millimeter. Breadth is 250 millimeter. Okay. Now let me open the PROKON software now. Concrete. Click concrete. Under the concrete tab here, you can see continuous beam. Click continuous beam. Now here, this is the interface. Now we'll assume as a grade of the concrete here, if see here you have to enter 25. Main steel grade FY is 460, FYV. Secondary steel, we assume 250 for the mild steel bar for the R6 link. Center cover to center top steel. Here, as per the other codes, American codes, as I explained earlier, The cover they defined cover up to the center of the main bar. This is the cover as per the American code. But the BS code cover how we defined this is the bar, this is the link. We define up to the link. This is the cover as per the BS code. So to give the correct input to the software, we'll calculate the exact cover, actual cover. Now here we assume 25 is the clear cover up to the link, and link diameter is 6 mm. So 25 plus 6, 31. 31 plus we assume the main bar diameter 16. So half of the 16 is 8. So 31 plus 8, 39. So we'll go with 40 mm. And the dead load factor is 1.4, live load factor is 1.6. Now here keep it in your mind. When you give the density of the concrete here 24, what software will do? Software will automatically calculate the weight of the beam. If we give this value as a 0, let me open the presentation as well. Once you give the density as a 0, what you have to do is you have to calculate the self weight of the beam manually, and you have to input the load separate. I'll explain how to input that one as well. For the time being, I'll put 24 here. Okay, I'll put here title simple supported beam. Okay, now let's go to the next step, section. Yes, section, you have to define any number. Section number 1 will say if you have so many sections, for example, if it's a continuous beam, you can define any number of sections. I will explain in next videos. For the time being, we'll take section number 1. Breadth is 250. Let's check this. Breadth is 250. Depth is 300. Okay. Okay. I'll click span. Span number 1. Section length I'll consider as 3 meter. Section number 1. So I will use left and right both same section. So if you want to change any section, for example, tapered section, whatever it is, you can give. Now here this is the 3D view of the beam. Okay. Let's move to the next one. Support. Here, software will automatically consider as a pin support. If you want to assign a fixed support, for example, support number 1, what you have to do is input support number 1 here, type code is F. So it will take a fix. Okay. Likewise, similarly, support number 2 is also fixed support. So you can put input number 2 and put type fix. So this is how we assign the supports. For the time being, I'll delete now because our beam is simply supported. Next one will apply the load. Okay. Now here, dead load case, span number 1, input the brick wall load as a 15 dead load. Here, what we calculated, 15. If you go to the parameter again, here already you have defined the density of the concrete as a 24. So no need to add the self weight of the beam here. But if you input this one 0, density of the concrete as 0, for the load, you have to add 15 plus 1.8, 16 point as a dead load. Because software won't calculate the self weight of the concrete once you give the 0 value for the density. So what I do is I'll put 24 here. I'll put the brick wall load as it is. And live load, span number 1, so 6.5. So this is the load diagram. So let's go to the analysis tab. View, click view, and this is the deflection. Here in the input tab, you have to complete all of this thing. This is the maximum bending moment value. This is the maximum shear force value. So this is the diagram. We can see the output file. This now next tab, steel requirement. For 38.16, we have to provide 378.5 square millimeter at the mid span. Shear force ASV over SV value, I'll explain later on, 0.46. Let's go to the output file. This is the output file. Here, see, you can see maximum bending moment is 38.16 at the mid span, 1.5 exactly, exact mid span, and 378.46. This is the steel requirement, right? And the shear force maximum shear is 50, capacity is 260, so it is lesser than the capacity, so it is sufficient to provide the nominal steel ASV of SV, nominal shear reinforcement. Let me share the code. Here you can see, as for the BS code, this is the older version, this is the new version 97. Code says that here how we obtain ASV or SV here from this formula. So in next videos, I will explain detail calculation, manual calculation, how to calculate the shear reinforcement and the bending steel, how to calculate manually in next videos. Here, look at this formula. Code says that our shear stress is greater than 0.5 VC, greater than 0.5 VC or less than VC plus 0.4. We have to provide minimum length for wall length of the beam. So this is our condition as per the software. SV greater than or equal 0.4 into BV SV divided by 0.95 FIV. This is the steel spacing, requires steel spacing of the link. So once I get this value, ASV over SV value, see here, I'll subject this one. So it is greater than or equal 0.4 times BV divided by 0.95 FYV. So this is the formula, right? So what software gives, BV we know, SYV we know, software will give this value, SV over SV value, right? Based upon this one, we can calculate the, for example, ASV over SV, it gives some value. We'll say X value. So based upon this one, we can calculate the SV value. Okay, this is the fundamental. Let's go to the software again. So this is the 0.46. I'll explain how we obtain 0.46. Okay, we'll calculate that one. Okay, let me explain first how we obtain the main reinforcement, right? 378. So we'll go to the reinforcing tab. Now this tab is over. Go to the next one, reinforcing. So 6 meter. So our beam time is normal beam. So here you can input number 1, normal beam. Minimum bar diameter, I'll assume 12 mm. Top for the top. Maximum bar diameter will say 12 mm because this is simply support beam. Load is very less. So based upon the experience, we can judge for the engineering judgment whether you have to use 40 mm or 16 or 20 for the maximum. For the time being, I'll put for the bottom also 12 mm minimum, maximum 12 mm sufficient. So I'll put minimum diameter for the stirrup 6 mm, maximum also 6 mm. This is enough. So I'll click generate reinforcing. Click OK, click OK. So here see, for the mid span, we obtain 40-12, right? What is the requirement of the steel? We need 378. Now here I will show one Excel sheet. Look at this. What is the steel requirement? 378. Cross-sectional area of number of bars. I'll put 379. So here, suppose Bar diameter is 12 mm. Two number of bars, it means 226. 3 mm mean three numbers means 339. If you provide four numbers T12, 452. So our provided steel area should be greater than the required steel area, as we know that. Provide either 4012 or else 2T16. So this is 402, 452, right? I hope you understand. So this is one method. Now let's go to the shear reinforcement. Okay. Okay, reinforcing. We'll go to the stirrup. Here, go to shear reinforcing. It gives 6 mm at 100 spacing, 100 millimeter, right? So we'll go to the 3D view and look at this. This is the here it curtail. Curtail means at the supports second movement is reduced up to 0. So we can reduce the bar. Mid span only we need more reinforcement. So PROKON will automatically curtail, right? So we'll go to the shear reinforcement. Here you can see steel requirement shear reinforcement, we need 0.46, right? So we'll calculate this one. Here ASV we are calculating 0.4 times. BV is 250. BV is 250 divided by 0.95. A mild steel grade is 250. So this value, this we can cut this too. So 0.4 divided by 0.95. How much? 0.4 divided by 0.95 is around 0.42. 0.42. But as per the older version, here in 1985, it gives this value 0.87. But the 1997, it gives the 0.95. So if you use older version, 0.4 divided by 0.87, this will become 0.459. So we can say 0.46. So this is the fundamental. What software will calculate here 0.46 is VSV. So what we will do, you can directly take this value as for the software, or else I'll share this Excel sheet. Go to the beam link. Here directly I input 0.46. Here ASV value, number of legs 2. So we have options. If you provide 6 mm, you have to provide 6 mm spacing. Here then only will get more than the requirement, 0.57. 0.57 is greater than 0.46, or else we can provide 8 mm bar, 200 spacing. Because we can't provide 225 means 0.45 lesser than the 0.46. So 0.5 to ASUSC to 10.5, you may provide 8 mm 200 or else 6 mm 100 spacing. So this is how we calculate the main bar and the shear reinforcement using the PROKON software. I have done the very simple example, right? Very simple example. So in the next videos, I'll explain how to calculate how to design a continuous beam by PROKON, as well as how to calculate the reinforcement by manual hand calculation, and some other videos related to structural design, how to analyze the structure with ETABS and SAP 2000 and StatPro. In the future, I will upload. Please subscribe the channel and follow the channel, and I will update regularly. So here, click the cal sheet, and what we have done, view tab, movement and shear, steel and output file we checked, and reinforcing we generated this one. We check the reinforcement and click final cal sheet. You can get the report. Here, software will give the report. What are the deflection value, what are the shear force value, what are the maximum bending moment, maximum minimum, and steel requirement. So you can get a print of this one. Okay. Okay. Okay, guys. Now I will save this one file. You can save. You can save. This is how we calculate the steel requirement for the simply supported beam. So in the next videos, I will explain the same example, how we calculate by manual calculation, and we can get the results. Okay, guys. So subscribe my channel, and if you have any doubt, put a comment and I will reply, or else you can email or you can WhatsApp. I will answer for your questions. Thanks you. Thank you.